So today I'm going to be talking about basically the performance issues that we dealt with at the Atlantic over the last year, how we overcame them, and some of the things that we learned on the way there. So I'd like to start off by thanking the organizers of DjangoCon for taking interest in my proposal, all of you for coming to listen to it. And I think one of the most valuable things about this conference, on par with the talks and the events, is the opportunity it presents to meet and talk to some really smart people. In fact, the work I did in the past year, what eventually became this talk, was thanks to a conversation I had with one of the founders of Opbeat. If you're not familiar with them, they're a service for monitoring performance of web apps, similar to New Relic, but with a special focus on Django. At the time, in September of last year, we were struggling with growing pains in our Django application. We had just completed a huge project, the porting of over 6 years of legacy code, a mix of PHP and Perl, to a Django-powered CMS and front end. There were a few performance hiccups at launch, but we eventually overcame most of those, with one important exception. Our servers basically melted when we deployed. At the time, we were using ModWhiskey, so our process was basically to tee up the code using a Fabric script and then touch the whiskey file. Today, as you can see, and you're reading that correctly here, 80-second response times, and now down to 150 milliseconds. So I'm going to first cover the things. There wasn't one single thing that we did that addressed our performance issues. It was a bunch of small things, a couple things that were actually low-hanging fruit that were great wins, but in general, it was a bunch of small things that build up to fixing our performance problems. So the first thing is monitoring and profiling. If you don't understand what your bottlenecks are and you don't understand where the slowness is occurring or where the app is freezing up, then you're just sort of stabbing in the dark. And I also think it's important to tackle the easy stuff first, in quotes here. Query optimization and caching are sort of pretty easy ways to get quick wins with the application. And also, this talk is very focused on the server side of things, but it's important not to neglect front-end performance as well, which is like a completely different ballgame. But you can have a super fast server and still your JavaScript takes 20 seconds to load and nobody visits your site. So for profiling, we found the most use with hosted services. New Relic or Opbeat are both comparable and great services, and we identified a number of really important performance issues in our site with those. Also, everybody I'm sure is familiar with Django Debug Toolbar. I recently came across Django Silk, which seems like a really promising application for sort of a different way of profiling your Django application. And if you're a masochist, you can always try cprofile, pyprof, 2calltree, and kcachegrind. And also there's some WYSGI middleware, which I've had mixed experience with. There was like one bit of code that I was able to kind of figure out where things were going wrong with that, but it was really difficult to set up and probably not worth the effort. Monitoring, there are downtime notifications, some of them hosted, a lot of the same services that provide performance monitoring, New Relic, Opbeat, and then also Alertra and Chartbeat provide the service as well. And then you can have self-hosted services like Nagios and its many forks, and also others like Zabbix. So with the easy stuff, caching, using a CDN, at the time that we launched, we did have a CDN, though we weren't using our cache headers properly. And so kind of being really strategic about where we said what to vary the cache on and when and how long to cache the page, particularly for archival pieces, really helped us with some of the traffic we got from crawlers and bots. Which is the majority of the traffic that gets past our CDN. It's important, I think, to have a proxy cache, whether it's Nginx, Squid, or Varnish. We use Nginx, and we've had a great success with it. One of the really great things about the Nginx proxy cache is you can actually set it up to just cache for 5 seconds or 2 seconds, but to hold the information in the cache as long as until there's a 200 response. So if your application goes down, that 2-second cache key will hold up until your site comes back up again. We've had this really save us. Somebody deployed some bad code, or there's an issue with the database and the site. Nobody really realized that the site was down. because we had this 2-second cache that basically lasted all night. Also with caching, the stuff that comes built in with Django, like the cache template tag, @cache property, cache static file storage to cache the information about where the static files are located on the file system, and the cache template loader, which does the same thing for the template finder. Page caching frameworks. We actually have one that I thought we had open sourced, and I realized today that we have it closed source for some reason. So I talked to my coworker, and we're going to open source it called Django Cache Cow in the spirit of sort of punny, stupid names for Django projects. It's kind of loosely based on Django Jimmy Page, which hasn't been updated in 3 years and still listed as alpha. So maybe it's an improvement on it. But there's also a number of really decent page caching frameworks. ORM caching, like Django Cache Machine, I feel like is a mixed bag. And I'll actually get to that in the next slide. So for query optimization, there's the obvious stuff like prefetch related and select related. Prefetch related objects, which is in 1.10 public, though it's accessible in earlier versions of Django, that allows you to pass a callable and filter the objects that you prefetch on so that you can prefetch conditionally items in the query set. For instance, in a generic foreign key, you can prefetch all of the instances of one model, this field, and not have to worry about it conflicting with other results in the query set that might be from different models that do not have that field. .values and .values list, I found this really surprising. When you're profiling Django, one of the things that we found to have like a huge impact, but which doesn't really show up in any profiling, is model instantiation and hydration. Because, and this is what ties back into like Django Cache Machine. We had a query that basically we stored in the database. We had all the different ad slots on our site, and then the breakpoints that they were enabled, and the sizes of the ad units. And all together with the prefetch relating and the select related, this amounted to, I think, like 700 instances being loaded into memory on every request, which came out to about 80 milliseconds, 100 milliseconds per request. When we switched this to just .values and manipulated a dict to basically simulate the prefetch related, like I said, 80 millisecond drop in every request. So that was like a huge gain. Basically made our response times about 25% faster at that point. And then obviously, but much more difficult, database parameter tuning and judicious indexing. And you can always throw more hardware at the problem. That was, part of our speed gains there was cheating. We upgraded from like 4-year-old servers to brand new servers that ran, twice as fast. So, that cut our response times in half. Now, you might notice from the earlier thing, the only thing in this chart is request queuing. What is request queuing? So to explain that, I'm going to rewind a little bit and just kind of talk about how we were set up. So we had, I think, what's a fairly standard way of load balancing a Django application. We had Nginx in front of it as a proxy cache, and then we had a couple of application servers. In this case, they were running ModWhiskey behind it. The Nginx was listening on port 80, and then we had the different applications listening on different ports and defined upstreams in the Nginx config across the different app servers. We also had a stage version of our site, which we would use to test out code in production on the production environment, and we just had like a different port for it. So, our directory structure looks something like this. The discussion I had last year at DjangoCon with the founder of Opbeat, so I was explaining to him this problem we had. We would load everything up. We would try and preload as much as we could. Then we would touch the WSGI file and then kind of cross our fingers. And if we happened to be slammed by a bot at that time, the site, all the code that it took to load, on our local dev machines, just loading up one worker process, it would take maybe 10 seconds. But on the server, loading 40 workers simultaneously across 5 VMs, which are all actually sitting on 3 bare metal machines, this could take 30 seconds, 45 seconds. And during that period of time, all these requests are queuing up. and basically the server, by the time the server's responding, it's still being overwhelmed by requests. And there were a few times where we had to do like rolling restarts of our server and actually bring them down and take them out of rotation in Nginx just that they could kind of cool off and be able to respond again. So what he suggested was, why don't you, rather than having like a stage and a live that are separate and you know, doing the switch basically like at the deploy time, load the code and touch the WSGI first, and then switch the symlinks. Basically have like A and B symlink to stage and live, so that you have the A and the B folders are always production ready. In any given case, one of them is either one version ahead or one version behind what's currently on production. But in every other respect, the CDN paths that they're using, the database, they're production. You force as much code as possible to load before defining your def application, your WSGI file. This is less important for ModWhiskey, but we switched to YouWhisky. And one of the things that's nice when you're using YouWhisky and you set up, again, with the sort of silly names for Python and Django projects, Zerg mode, where you have like the way Zerg mode works, you have a Zerg server, which is really very bare bones. All it does is it just like listens for workers. And then the Zergs, when they come online, they communicate to the Zerg server that they are accepting requests. And it's only at that point that the Zerg server routes requests to them. So this gives them the freedom to sort of take as long as they need, basically, to get everything loaded up into memory and preload everything before it even needs to deal with the incoming requests. And the Zerg server handles the queue. And then before swapping the upstreams and after they've been preloaded, we warm them up with a number of simultaneous concurrent HTTP requests that basically make sure that all the workers get a request with a cache-busted URL so that they're all primed. So why did we switch from ModWhiskey to YouWhisky? There's, I think, a lot of misinformation about whiskey servers and performance benchmarks and things like that. I think generally the comparisons and the configurations aren't very reliable, and the thing being tested often doesn't apply to the real world. There's something like, how many concurrent hello world responses can you serve up at any given moment? ModWhiskey, in general, it's comparable performance, like I said. It runs on Apache HTTP server, which is, whatever. Mostly the work of a single developer. The documentation is terminally out of date, and important configuration options are missing or only discoverable in the release notes, which is something that's openly admitted in the documentation. Kind of like the summary of the GitHub pages kind of demonstrates the balance between where the community's gone with ModWhiskey and YouWhisky. So YouWhisky, broad and active community, very thorough documentation. In fact, it's kind of overwhelming, but also highly configurable. And so when I was rehearsing this talk, there were a couple slides that I don't think I'm going to have time to get through, but I do have a GitHub repository which has some demo code that kind of demonstrates how we're using YouWhisky Emperor mode and Zerg mode and the YouWhisky stat server to kind of monitor our WSGI applications, preload everything using a Fabric script. So I'll just sort of refer everyone to that and sort of as a teaser kind of show what our YouWhisky monitoring page looks like. So it looks something like this. We use Emperor mode. Emperor mode basically is a way where you can dynamically set up multiple configurations for a single code base. So we have like one really large code base that hosts all the Atlantic properties, CityLab, The Wire, theatlantic.com. We have a profile site, which is for people to manage their print subscriptions. We have a sponsored section of the site. And we have an A and a B version of all of those things. And then also we have a CMS that's for our editors and a CMS called Waldo that's for outside video contributors. So we go to this page. We can see in real time as requests come in. There we go. It sort of changes. You can sort of hover over the little dots to see information that's pulled from the YouWhisky stats server. If the site starts to get overwhelmed, there's a little queue monitor down at the bottom. Generally, if the queue fills up a little bit, that's normal. That's sort of expected. And we have one of the things you can do with the Zerg mode is dynamically spin up instances based on how busy the other worker processes are. So, when these requests come in, spawns new processes, and then it's able to handle the increased volume that's coming in. So up here, these are the URLs to the GitHub repository. I actually haven't pushed it yet, but by the time this video is online, it'll be there. I think it'll probably be sometime later this week. At Frankie Dintino, I don't really use Twitter much, but it's an easy way to get a hold of me, or you can email me, frankie@theatlantic.com. And with the time I have left, I'll open it up to any questions.
Great talk, thank you. So first question, or just the question is basically all end user traffic that hits the Atlantic.com served like through CDN, but then that CDN is basically talking to Django across the board. So is the entire site served off of Django, I guess is the high level question. Yeah, well, mostly. I mean, there are a couple of really, really random legacy pages that look really old, and they are really old. But 99% of the traffic goes through Django. And like homepage and like all the homepage, all that traffic, right? Yeah, and as far as the CDN is concerned, so a small portion of the requests will get through the CDN. We generally have about a 3-minute page cache for every page, and then we have longer ones for some, older pages that haven't been updated in a while. But most of the requests that get past that are actually bots and crawlers. We have an archive. I mean, we've been printing since 1857, and we basically have everything online that we have the rights to. You would think that a print magazine would have digital publishing rights to all their articles, but you would be wrong. That is not the case. But everything that we do have the rights to and that we've digitized is free online. So, we don't generally have an issue when people crawl our site if they're doing it in good faith, but occasionally there's like an AWS instance that'll make like 200 concurrent requests every second and sort of makes our servers melt, and so we have to kind of scramble to block it. And so a lot of this was like kind of dealing with that and getting us in a place where we could handle those sorts of situations without breaking a sweat. Great, thank you. Sure.
Hi. So you talked about using ModWhiskey and switching over to YouWhisky. There's a third option that a lot of people use, which is GUnicorn. I was just wondering if you thought about GUnicorn and didn't go with it, or just didn't have time and you had seen how big YouWhisky was. Do you have an opinion on that?
I don't, actually. I know people have had a lot of success with it. I don't really have a strong opinion one way or the other. Just kind of YouWhisky worked for us, but I think it's on. From what I understand, GUnicorn is on par with YouWhisky in terms of features and performance.
So you didn't like look at GUnicorn and decide like, oh, that's not going to work for us.
No.
Okay. Thanks.
Sure.
Yeah, you mentioned earlier that you thought some ORM caching was kind of a mixed bag. Can you go into more detail why you think so?
Sure, yeah. So when we ran Django Cache Machine for a really long time on our site, and then actually kind of accidentally we turned it off. And this wasn't the first time we've accidentally turned off caching. But in this case, there was really no performance difference. And we kind of speculated about why that might be. The conclusion we came to is that a lot of the, so our situation is maybe unique because we're not in the cloud. We're in a data center. It's all, in Reston, Virginia, all connected via fiber channels. So there's not much latency between the servers and the database. And the database is pretty well tuned for reads because we don't have a lot of writes because we're, the editors publish maybe 20 stories a day versus people reading millions of stories a day. So the database is generally not a bottleneck for us. And the model instantiation and hydration, and basically the unpickling and creating of the model instances, was taking almost as much time as if we were doing it raw ORM queries to the database. So it really didn't make a big difference. But I think that In cases where you're like on a cloud, where there's latency between your application servers and your database servers, or when you have situations where like writes and reads are more balanced, then I think there might be a, like I said, a mixed bag. Then it might be useful.